So in previous video we discussed regarding inference rules, closure set of uh, functional dependency and attributes, equivalent set of functional dependencies. So as we know that in those videos we discussed regarding how to derive the new functional dependency with the help of inference rules. Now in this video let's discuss about reducing the set of attributes and functional dependencies with the help of same inference rules that we call as minimal cover. So minimal cover is minimal set of functional dependency, reducing the number of functional dependency in the given functional dependency. It is reverse of your closure and the equivalence. In the equivalence and closure, you are deriving the new functional dependencies from the given functional dependency with the help of inference rules. Whereas here you are reducing the given function. In the given functional dependency, what are the functional dependencies are there? That one you are reducing here. So that is what we call as a minimal set here. A set of functional dependencies is minimal if it satisfies the following condition. When we call that one as minimal, every dependency in F has a single attribute for its RHS. Right hand side, if you are having the single attribute, so then we can call that one as a minimal. We cannot remove any dependency from F and have a set of dependencies that is equivalent to F. After applying the inference rules, so it is not possible to remove any further dependencies in a given F. So then we call that one as a minimal. Next, we cannot replace any dependency X determines A in F if the dependency Y determines A where Y is proper subset of X. That is, Y is subset of X and it still has a set of dependencies that is equivalent to F here. So now in the given functional dependencies, so you have to check. Your aim is if you want to find the minimal cover or minimal sets. So in the right hand side, we try to get the single attributes, and in the given functional dependency, we try to get the minimum number of functional dependency. Further removing the functional dependency after applying the inference rules, if it is not possible, that set we call as a minimal sets of functional dependencies. So every set of functional dependencies has an equivalent minimal sets. So even in the functional dependencies, you are having the equivalent minimal set. There can be several equivalent minimal sets. So in the given functional dependency also, subset of functional dependencies are there. Those are equivalent. Okay. So those we call as a equivalent minimal sets here. So maybe single or maybe set of such type of the equivalent minimal sets may be there. There is no simple algorithm for computing a minimal set of functional dependencies that is equivalent to a set of F disks. To synthesize a set of relations, we assume that we start with a set of dependency that is a minimal set. So now to find the minimal set, getting the minimal set is not an easy task. So we need to find that one. So for finding that, we need to apply the different inference rules here. So that algorithm is not a simple one, and we need to synthesize a set of relations. So for that, first thing is what are the functional dependencies are available. That one we consider as a minimal set, and will further continue with the by applying the different minimal inference rules, and we try to reduce the number of functional dependencies and number of attributes on right hand side here. So this is the algorithm which is used to find a minimal cover F for a set of functional dependencies E. E is the given functional dependency set, and we need to find the minimal set for F here. Input for this algorithm is a set of functional dependencies E. E is the given set of functional dependencies. So as we told earlier, first we assume that what are the set of functional dependencies are available in E or F now. Because I don't know whether it is a minimal cover or not, but I'll make the assumption that this E itself is the minimum cover now. Next, later I'll replace each functional dependencies X determines A1, A2, A3 in F by the n functional dependencies. X determines A1, X determines A2, X determines AN. It is, so what are the functional dependencies are available in F? So now I need to reduce that one. So for that I use the decomposition rule. So in the decomposition, what is the thing I done here? So I taken the, if you are having the set of attributes are functional dependent on X, each attributes will take like this. X determines A1, X determines A2, like that. How n attributes if it is there, then you are taking the n functional dependencies by applying the decomposition. For each functional dependency, so for each means what? For this functional dependency, for this functional dependency, we need to check for each attribute B that is an element of X. So here X is what? It is X is a set of attributes. In that you are considering the each attribute. B is what? It is an attribute of X here. If F minus X determines A, union X minus B determines F. This is your given functional dependency where you are having the X determines A here. So in the same way, in the X, number of attributes may be more. In that, if I remove one attribute, this B is the one attribute. If I remove that from the X set, and after that also this functional dependency does not make any difference. If it is equivalent to F, then what is the thing you have to do? Then you replace X determines A with the X minus B determines A here. So X contains set of attributes. Among those attributes, if I remove any one attribute, after removing that attribute also it doesn't make any difference to your functional dependency, then thing is what? You have to remove such type of the attributes from this X side. Okay. So if I take like example, so if I take the functional dependency, X is what now here? As a name. Okay. Next is USN. So this name and USN are among the X side. It determines your branch. Okay. So now among this X, if I remove this name, B is what now here? B is the name. Okay. If I remove this name from the X set, so later after removing this name also, this branch is dependent on USN. USN determines branch. It doesn't make any difference if I remove name from this functional dependency. In that situation, you remove this attribute B, that is the name here. That is what actually step 3 tells. Next, step 4, for each remaining functional dependency. So now in the functional dependency, how many functional dependencies are available in this functional dependency set F? If I remove any functional dependencies from this given set, later also it doesn't make any difference to your remaining functional dependencies, then simply you remove that functional dependency S determines A from F. For example, if I take, okay, A determines B, okay, and also I'm having B determines C, and A determines C here. These are the three functional dependencies available in F here. So if I remove this A determines C, so from this given functional dependency, it doesn't make any difference to your functional dependency. Why? Because with the help of the third inference rule, transitive rule, so I can derive that functional dependency A determines C here. So that's why if I remove this functional dependency from the given functional dependency set, it doesn't make any difference. That is what we comes under in this okay, fourth step of the minimal sets of functional dependency. This is the algorithm used to find the minimal set of functional dependency. So step 2 what it tells, first you apply the decomposition rule. Next step 3 what it tells, in the X side, that is in the right hand side. So if you are having more than one attributes of, okay, so then try to remove the number of attributes in the RHS side. After removing also, if it doesn't make any difference to your functional dependency, you simply remove here. Fourth step what it tells in the set of functional dependency with the help of the available functional dependency. If any functional dependency if I remove, if it is not possible, if it doesn't make the any difference to your given functional dependency, with the help of the remaining functional dependency I can derive that one which one I removed. Then such type of the functional dependency you remove from the given set here. So by applying these steps you can get the functional dependency set at the end, and that set is always minimal sets of functional dependency. Okay. So let's take one example here. Given the set of functional dependency E. So E contain the set of functional dependencies. What are those? B determines A, D determines A, B determines D here. My aim is what now? We need to find the minimal cover for E here. So for minimal cover we need to check here. So one thing is what it is. First step is what it is. This E I'll take as a minimal cover as a F here. So I'll take this thing. Later I try to reduce the number of attributes on left hand side. So but in the left hand side you are having the single attributes. That's why I am not going to the second rule, that is the decomposition. Next, third rule what it tells, try to reduce the number of attributes in the right hand side. So in the right hand side you are having the B single attribute here, D single attribute, but here you are having the two attributes here. So then my aim is what? I try to remove the any one attribute from this. After removing also it doesn't make the any difference to your functional dependency, yes, then remove that one. But thing is what? AB determines D has a redundant attribute on left hand side, that is it can be replaced. Either you can replace that by B determines D or A determines D here. So for that what is the procedure I have to check? I have to prove that. So if D is functional dependent on B, then you remove A. If I prove D is functional dependent on A, then I can remove B here. So directly I'm not getting that, because whether it is dependent on B or A I don't know. So for that what is the procedure I have to do? By using the inference rules I try to check whether it is depends on B or A here. So here given functional dependency is what it is, B determines A. So for this B determines A, by using augmenting rule I added same B on both the side. So BB determines AB, or B determines AB. Same thing you repeatedly if you are right, it doesn't make the any difference here. However, AB determines D as given in 2. Here they given B determines AB, and here they already have in the functional dependency as AB determines D here. This is given. AB determines D is given. Now I prove that is what it is. B determines AB by applying the augmentation rule for this given functional dependency. B determines A here. Yes, later after that if I apply the transitive rule, so that is what it is, B determines AB, and given that is what, AB determines D here. So if I apply the transitive rule, I will get to know that B determines D here. So then what is the thing I have to do now here? So now this is your given functional, minimal, this is your given functional dependency set. After proving this, I get to know that this D is dependent on B here. So then this is having the set of equivalent to original functional dependency E. That one I have taken as E dash. E and E dash both are same. I use this one. B determines A, D determines A, and B determines D here. So this is the step in the minimal side. First aim is what? You have to reduce the number of attributes on X side. As here you reduce the number of attributes on X side. Next step. Next step 3 what it tells, you need to check whether the removing of any of the functional dependency, if it is possible, after removing that with the help of the remaining functional dependencies in given set, is it possible to derive with the help of the inference rules or not. So now here this is the given functional dependency, that is whatever I got after applying the one of the step of the minimal cover. Next is, now I reduce the number of attributes on X side. Now okay, next step is what it is. You have to reduce the number of functional dependency. So here they given B determines A and D determines A and B determines D here. Yes, same thing. So B determines A. Okay. So next is what it is. B determines, okay, A it is there. So now this one, if I remove, I can get this functional dependency with the help of these two functional dependency. Yes or not? Let's see. By using the transitive rule, B determines D, D determines A. So this is the D determines D and B determines D. These are the two functional dependencies. With the help of transitive rule, I can derive this B determines A here. So that's why if I remove this functional dependency from the set, it doesn't make any difference. Yes, that's why I remove that. I got the okay new functional dependency set, that is B determines D and D determines A. Okay, after applying this step also, first step is what it is. You have to decompose the attributes, okay, using the decomposition rule. Next, try to reduce the number of attributes on X side. After that, try to remove the set of functional dependencies. After removing that also, if you are getting that functional dependency with the help of the remaining functional dependencies, then you remove that. So now at the end, what are the result? You will get know that is your minimal cover for that particular functional dependency set here. So here functional dependency set is given as E. For that minimal cover is this one. B determines D and D determines A. So this is how to find the minimal cover for given functional dependency.